Hey everybody, welcome to solving out right triangles. So in this video, I'm going to use sine, cosine, and tangent, their ratios, as well as inverse sine, inverse cosine, and inverse tangent to do two examples. One example is just going to be a straight, hey, here's the triangle, tell me all the sides. The other example is going to be a word problem, so you'll see me solving out a word problem using some right triangle trigonometry. So here we go. So our first one, solve this triangle. So what do I need to know? I need to figure out this side B, I need to figure out this angle B, and I need to figure out this side A. Well, let's start with the easy stuff. So the easiest thing to figure out here would be this angle B. Why? There's 180 degrees in a triangle. I know that's 90, I know that's 12, so I can figure out B. So 180 minus 90 minus 12 gives us 78. So B is equal to 78 degrees. All right, got that one. Okay, now I just need to figure out side A and side B. Let's use let's use angle B, in which case I have an adjacent and a hypotenuse, so I'm going to use cosine. So cosine of 78 then is equal to the adjacent side, which is A, over the hypotenuse, which is 19. Okay, multiply both sides here by 19, 19, those guys clear, so we get that A is equal to 19 times cosine of 78. So 19 cosine 78, we get 3.95, I'm going to call that 4. So A is 4, and I've heavily rounded here. Okay, now I need to solve B. I could use Pythagorean theorem, but I'm going to use trigonometry instead. I'm going to use the 12-degree angle here, in which case I again have an adjacent because it's touching, an adjacent and a hypotenuse, so I'm going to use cosine again. So now cosine of 12 is equal to its adjacent side, which in this case is B, over the hypotenuse, which is still 19. Okay, so again, multiply both sides here by 19. 19, and side B in this case is equal to 19 times cosine of 12, 19 cosine 12, 18.6. 18.6 is 18.6, and we're all the way solved out. Okay, let's get to our word problems. This is kind of a warm-up getting into the one word problem we're going to do here. Okay, now the challenge problem. So what do we have here? A radio tower is located 450 feet away from a building. Okay, so let's draw ourselves a little picture. So a radio tower, here's the radio tower, it's sending off its radio waves into space, and there's a building, here's the building, here's a window, there's a door to get into the building, doorknob, there, building. These guys are 450 feet away from each other. Okay, so I got that. From a window, oh, good thing I drew a window, a person determines that the angle of elevation to the top of the tower is 37 degrees. Okay, well, angle of elevation. So here is, suppose this person is in this window. So here is the person's completely straight 0 line of sight, right? Because you're looking out straight, you're looking at an angle of 0. When you look up, you start to get an angle of elevation, and then when you look down, you get an angle of depression. So this angle of elevation to the top of the tower, so that's from this person here to the top of the tower, the angle of elevation here is 37 degrees. Okay. We also know the angle of depression from the same person to the bottom of the tower is 41. So here's their kind of 0 line of sight. So now they're looking down. Here's their line of sight to the bottom of the tower. They're looking down at an angle of 41 degrees. Okay, how tall is the tower Well, if we can see here, we have that's a right angle here, and that's going to be a right angle here. We have two right triangles that if we can figure out this side of this triangle and this side of this triangle, we can add those two together, and that'll give us the height of the tower. So let me draw these separated. So here's one triangle. How long is this side? Well, it's 450 feet. 450 feet. It has this angle of 37. That's a 37, not squiggly 7. That's a right angle. That's the side I want to know, and we just don't know the hypotenuse right now, which is okay. This triangle down here, I'm going to set it up the same way. So it's a little bit flipped over. So here's my right angle here. I know that this length here is 450 because it's the same as this length here. So this base is 450. The height here I don't know, but it's what I want. And I also know this angle here, which is this angle here, is 41. So I've plucked these two triangles out of my drawing, and if I can figure out x and I can figure out y, and if I can add them together, I will get the height of my tower. So this is how I'm going to approach this. Okay, so I want x, and I know that this angle here is 37. So from this angle, I have an opposite side, and I have an adjacent side. So who does that? Tangent. So tangent of 37 is equal to my opposite side over my adjacent side. Now solve this, multiply both sides by 450. 450, 450, and we will get, those guys cancel. I'll get x is equal to 450 times tangent, 450 times tangent of 37, which gives us 339.1. 339.1. Okay, we figured out x. 339.1. Now we need to figure out y in kind of a similar fashion. Okay, same thing, 41 degrees. I have an adjacent side and I have an opposite side, so I'm going to use tangent again. So tangent of 41 is equal to opposite over adjacent. The same thing, I'm going to multiply both sides by 450 to clear the 450, get y by itself. 450, and those guys clear, so I'll have y. So y is equal to 450 times tangent of 41, which gives me 391.2. 391.2. That equals 391.2. So how tall is this tower? Well, it's these two things together. So height is equal to 339.1 plus 391.2. 391.2 plus 339.1. That gives us 730.3. 730.3 feet. And we're done. So the new thing, angle of elevation, angle of depression. If you look straight out, your angle is 0. Okay? Getting two right triangles, knowing what we know about right triangles to help us solve for sides of right triangles, combining these two things to get the height of a radio tower. So I hope that was helpful today. I hope you guys liked the two examples that we had. Whenever you guys have questions, please, all you have to do is ask, and I will see you guys in the next video.